This is a very common trigonometric identity that we have been using in all our numericals, and you must have seen several ways of proving this identity. So here is an interesting way which would help you remember this identity forever. And the way we are going to prove this identity is by focusing on this red line right here. So there are two ways of arriving at the length of this particular red line, and if we equate the two ways, we will get this identity. I'll just give you a minute to figure it out for yourself, and of course, if you are a very visual person, then you will find it easier. If not, then let us walk through it step by step how we are going to prove this using this red line. So this is an isosceles triangle. We can clearly see that. And if I make the angle bisector of this isosceles triangle, it will also end up being the perpendicular bisector of the opposite side. So that's the property of isosceles triangle we all know. Now with this, if I draw the perpendicular from this side on this line right here, okay, this angle is going to be x. And why is that? So that is the first thing that we are going to show, that why is this angle, why does it have to be x? So the reason is, see, this is x and this angle, let's say that it's y. In this particular triangle, if you look at this one, A, B and O, okay, so in this particular triangle A, B, O, if you look at this angle x plus angle y is equal to 90 degree. So we know that. Now if you look at this triangle CBH, this triangle, again this angle y plus whatever the angle right here is should equal to 90 degree. But we know that x plus y is 90. So this angle y, because it's common, this angle has to be x. Okay, so with this understanding that this angle is x, now it becomes very easy to actually show this identity. So first let's look at this triangle, the triangle number 1 right here. We know that because this is hypotenuse and the hypotenuse we have taken it to be 1, this length from BO is actually equal to sin x. Similarly, the length OC is equal to sin x. So in this length BC is nothing but 2 sin x. And with this given, we can now, if we look at this triangle BHC, and if we use this angle x and this length being sin x, this length actually becomes, so see, this 2 sin x is the hypotenuse. So this length, this particular length right here, in this triangle HBC, this length becomes 2 sin x cos x, which is our right hand side. Okay, so right hand side we have just arrived at that. So this becomes 2 sin x cos x. Okay, so that we had now arrived at. Now let us look at the other triangle. So what is the other triangle? The other triangle is right here, AHC, this triangle, AH right here, C. In this triangle, this angle is actually equal to 90 degree. Now because this angle is 90 degree and this hypotenuse is actually equal to 1, the length of this side right here, we can also arrive at the length from the length of HC from this triangle AHC. It also it arrives as sine of this angle is x plus x, which is equal to sine 2x. Okay, so there are two ways of calculating the length of this particular side HC. Using one way, we arrive at sine 2x. Using the other way, using the other triangle, we arrived at the length 2 sin x cos x. So of course those two lengths have to be equal, and in this way we have shown that sine 2x is equal to 2 sin x cos x. Now of course there are more general ways of proving this formula. This formula does not only holds for the angles which are between 0 and 90 degrees. It is more general formula. But if you understand this process, if you visualize it this way, you will never forget this particular formula. And of course, you can always expect a problem based on this concept. And if you know few things, few geometric visual things like this, it will always help you in solving such problems. Thank you.